So on the next part, I'm going to continue with section 6.3, and for the next example, what I want to do is I want to find the values of the trig functions again, but now I'm given sine of theta is equal to radical 5 over 5, and cosine of theta is equal to 2 radical 5 over 5. So using this, we're going to go ahead and again find the exact value of all the trig functions. So we're looking for sine of theta just like before. We're looking for cosine of theta, tangent of theta. We're looking for cosecant of theta, secant of theta, and cotangent of theta. And some of these are actually already given to us within the problem. So we know that sine of theta is equal to radical 5 over 5, so sine of theta is radical 5 over 5. Cosine of theta was also given to radical 5 over 5. Then tangent of theta is equal to sine over cosine, so it's radical 5 over 5 over 2 radical 5 over 5. And if we simplify, we're going to get 1/2. So I'll leave this simplifying to you guys. For cosecant of theta, it's a reciprocal of sine of theta. So we take 5 over radical 5, so we can also rationalize if we wanted to. For secant of theta, it's 5 over 2 radical 5. Again, we could rationalize this one if we wanted to. And for cotangent of theta, take the reciprocal of tangent and you get a 2. So if I did want to rationalize cosecant of theta, multiply the top and bottom by radical 5. So then I'm going to get 5 square root of 5 over 5. If we simplify, the 5's are going to cancel and you get back radical 5. So one possible answer is 5 over radical 5. Another possible answer would be square root of 5. Now what we're going to do is we're going to use the trig identity. Sine squared plus cosine squared is equal to 1. Tangent squared plus 1 is equal to secant squared. Cotangent squared of theta is equal to cosecant squared of theta. So basically we're going to end up using the identities that we have here in this worksheet in 6.3. So the ones that we're going to go ahead and use are, or one of the ones that I'm going to go ahead and try to use is sine squared of theta plus cosine squared of theta is equal to 1. 1 plus tangent squared of theta is equal to secant squared of theta. So it could be x's or it could be theta, same thing for this one. 1 plus cotangent squared of theta is equal to cosecant squared of theta. So let's go ahead and find the exact value of the trig expression, and what we want to do is we want to use identities. Whatever identity is going to make it easier to solve or to simplify. So we're going to find sine squared of pi over 7 plus 1 over secant squared of pi over 7. So in order to simplify, what I'm going to do first is I'm going to go and rewrite this secant squared as 1 over cosine squared. So we could go and use that if we wanted to, or we can use secant squared is equal to tangent squared of theta plus 1, or we can use, again, secant of theta is equal to 1 over cosine of theta. So these are two options that I have. Secant squared of theta is equal to tangent squared of theta plus 1, or secant of theta is equal to 1 over cosine of theta. But which one's going to be more useful to me? So this one right here is going to be a little bit more useful, so let's go ahead and try this one out. If I tried using this one, I'm going to get tangent squared of theta plus 1 in the denominator, so it's going to make this fraction even messier than it already is. So let's go ahead and try this one. So this is equal to sine squared of pi over 7 plus 1 over, instead of secant squared, I can rewrite secant squared of theta as secant of theta, and this quantity is being squared. So let's go ahead and use this rule here also. So this is secant of pi over 7 squared, and we know that secant of theta is 1 over cosine of theta. Well, in this case, theta is equal to pi over 7. So let's go ahead and simplify further. This is sine squared of pi over 7 plus 1 over, again, secant is 1 over cosine of whatever angle we're given, pi over 7. And this quantity is still being squared, so carry that square with you, and then you get sine squared of pi over 7 plus, And let's go ahead and simplify this portion. So 1 over 1 squared, that's going to give me a 1. Cosine of pi over 7 squared, that's cosine squared of pi over 7. Well, now I have a fraction within a fraction. So we're going to go ahead and simplify that. We get sine squared of pi over 7 plus cosine squared of pi over 7. If I take 1 times the reciprocal of this, I'm going to get 1 times cosine squared of pi over 7 over 1, which is equal to cosine squared of pi over 7. So now we're going to go ahead and use another identity. The only identity that we have that combines sine squared and cosine squared is the Pythagorean identity. So this Pythagorean identity, sine squared plus cosine squared is equal to 1. So let's go ahead and in this section, again, we're going to use sine squared of theta plus cosine squared of theta is equal to 1. In this case, theta is equal to pi over 7. This angle can be anything that we want it to. So as long as they're the same angle, this is still equal to 1. So the exact value of this expression is actually just equal to 1.